Hello, I am not dead, contrary to popular belief and want. I am still here, and this is episode 7 of me hopefully teaching you guys coding shit. That's what I'm renaming the series to. This is number 7, and today we're going to do something, pretty much one of the last two major things before you can go, fuck, this is all making sense, hopefully. And that's arrays. Ooh, spooky. What are arrays is what we're going to learn first, and then we're going to work out how they work. We're going to learn how they work and how they sit in your computer's memory, and then we're going to learn how to use them. I did have a fourth thing on it, but I don't think we'll be doing that because that requires some advanced knowledge, and I didn't really remember that part. Now, I'm not going to lie, when it comes to arrays, you don't... I don't want to say that you don't use them, because you do, but I can't remember the last time I actually used like a raw array, just an array. It has been so long since I've used one that I actually don't remember the syntax for them. And I've got notes up. That's what I was just opening in my web browser, some notes on the syntax. Like, I know how they work, I know how they sit, I know how you do stuff with them, but just like some of the little fiddly syntax bits, it's a little bit strange to remember when you literally don't use them at all. So why am I teaching you them if you don't use them? Fundamentals, my friends, fundamentals. And it's extremely important that you do learn arrays, because the things that make you not be able to use arrays underneath or other kinds of sticky shit, and they also act like arrays, so it's good to know them. When I say act like arrays, you can use the same array syntax to make them work. And they're really cool. So let's go into the basics of what an array is. An array is a contiguous block of memory that you assign multiple values to. Okay, what does that mean? So let's go into my trusty Excel spreadsheet here and go, okay, I want to create an array. I'm going to call it my numbers as opposed to my number. This is going to be an array of integers, and I'm going to say it can hold 10 integers. What that means is your my numbers variable, instead of holding one number, it holds 10, and you can access each chunk of it. So I can go my numbers, let's move it down the line, and go first number's 2, then 5, and 7, then 9, then 13, then 17, then 15, then 19, then 21. Stupid. And then one more, we'll go 23. Almost got prime numbers. That one isn't a prime, and that one isn't a prime, and that one isn't a prime. Sue me. So this here is the my numbers array, and it represents 10 digits. What kind of cool shit can we do with this? Well, if you remember loops, you can go through all 10 numbers and do the exact same operation on all 10 with a loop. You can add all the numbers in an array together. You can have an array that can hold 1,000 numbers, and then you just sort of get the user to keep feeding you data until they get bored, or until they run out of data to give you. And then you don't have to have like variable 1, variable 2, variable 3, variable 4, and you have this like 1,000-line long menu that says, what's your first number? This. What's your second number? This. And then input it to number 1, and number 2, number 3, etc., etc. You can just go, the first element of my numbers is the first thing you give me. The second element of my numbers is the second thing you give to me. And then we can go from there. So, why do we use arrays over, well, multiple values? Well, just for the reason I just gave you. Arrays are very important when you need to store an unspecified amount of data. When it's not just going to be, you're making a simple calculator, it's just going to add two numbers together. You're only going to have 2 digits. Maybe you want to take up to 100 digits that you can add together. Maybe you're going to take, you can have a storage database of 1,000 things that you can store, like 1,000 phone numbers. The weather's fucked. And then you need to know, how do you reference it? You can't go, all right, so I want to have the 5th phone number. Then you have to have this big if statement that goes, if the number that they gave me is number 1, you give it the first element, the second number, etc., etc. That would be such a pain in the balls. With arrays, it's all very simple. So let's just look at some very simple, an array. Let's just do exactly what we just did. So the syntax for making an array is the same as making a variable with a little bit of a modification. So you have your data type and you have your variable name. And then you have open square brackets and the storage size. In this case, we've got 10 and close square brackets. That is setting aside 10 integers all in a row under the name my numbers. Well, how do we give this data? Well, we can do a couple of ways. We can go my numbers, then the element we want to access. Now, this is a bit of a thing to get your head around, and I'll explain how it all works, so hopefully it sort of drives it into your brain. Arrays and most things in programming are zero-based. So the first element is 0, the second element is 1, etc., etc., etc. The reason that is because of the mathematical formula behind working out where you want to go. So let me show you this. So what was our first number? It was 2? 2. Okay. Now the way this works is, so this is element 0, 1, 2, 3, 4, 5, 6, 7. Whoops. I've turned off numlock. 7, 8, 9. Yeah, so that's that. So the way this works is, let's say my numbers is at memory address 0, just to make it really, really fucking simple. So, and each, so that's the start address, and the size is going to be 4 bytes, an int is 4 bytes, at least on a 32-bit machine. So the way we get any of this element is the formula is the start address, so this, plus whatever our offset is going to be. Oops. Oh, I tried to hit shift, times our size. So offset, if we say offset is 0, it means the very start of the memory, we're at the very start, and that is where this guy is going to sit. We move over 1, we're at byte 4, and this is where this is going to be. So from byte 4 to byte 7, that is where the second element is. So it's an offset. It's not. It's an index to which number you want, but they use that as an offset from the start. So when you're at the start of the array, you are 0 from the start. When you're at the next element, you are 1 from the start, etc., etc., etc. Hopefully that makes sense to you, and I'm sure it'll become second nature. It is, something that you get used to extremely quickly. But sort of knowing why rather than just knowing what it is, I think really does help. So just like a normal number, your first, my number, so just call it number. It's going to be at address, 20 or whatever. And then from 20 to 23, those 4 bytes, that is your data. An array works the same. From the very first bit to whatever size over, that's your data. And then if you want to jump over that, you have to start at the next one. So your offset is then 1 times the size plus the start and blah, 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 blah. Anyway, so let's actually just fill out our data. Is that 9? No, now it is. So let's fill it out to look. You know what? If I was smarter, I would have done this better. 13. Yeah. I go hit the 17 and then 15 and then 19, 21, 23. Cool. There we go. 1, 2, 3, 4, 5, 6, 7, 8, 9. Cool. That's our array. That's how you assign data to something in an array. It's the exact same way you assign data to any other kind of variable, with the exception of the array notation. And the number inside, once again, is the index, which is the offset from the beginning. So it's 0 based. Just -1. In your head, if you need to do it, just -1. I want the first element, it's number 0. Easy. How do we output stuff? People who have gotten the way this works will probably figure it out straight away. All we need to do is do the same thing. My number's 0. It's the exact same way as you retrieve a normal data, except you've got the index notation. So let's cheat a little bit. I forgot 1. Dang it. Dang it, Bobby. Cool. Now let's run our program. We should get 2, 5, 7, 9, 13, 17, 15, 19, 21, 23 on the screen. But I've selected the wrong thing to build, so let me just fix that, because I am dumb. Set a startup. I don't generally jump around startup projects, but there we go. We have exactly what we want. But right now we are using an array just like 10 normal variables, and that's not something that programmers do. It becomes pointless. Like, why would you do that? So let's use it like we're programmers, like we're engineers. That very wanky term that everyone seems to hate. Let's delete all this. Now, at the start, I talked about how you can use loops and how you can do cool stuff with loops. When we did loops, I taught you the for loop, at least I hope I did. And the for loop is used mainly for iterating over stuff like arrays or lists or any other kind of like data like this, which has an index to go into it. So if you don't remember the syntax for a for loop, or if I just forgot to teach you it, it's for, then you have some kind of initialization, then you have your loop condition when you have to continue and when you have to stop, and then you have your end of loop function thing, which is usually just incrementing your variable. So you go up by 1 or 2 or 10 or 20 every time, usually 1. This for int I equals 0, I less than some number plus plus I is basically autopilot for most programmers, because I is used very often as the loop variable. So this is what we can do. We'll not count, cout my numbers, and then we can use I, because it's just an integer your index, and end line. Oops. So now what we're going to be doing is printing out index 0, going around, printing out index 1, going around 2, 3, all the way up to 9. So we get this, and we run it, and it's exactly the same as what we had before, which is perfect. Now, at this kind of rate, you might not think it's kind of useful, but when you have 10,000, 100,000 million items, which is not that unusual, especially if you're working with large data sets, which that is, it's extremely handy. At work, I have like one of the smaller, this is a very stupid sentence, one of the smaller, bigger data sets is like 200,000 entries of people that we have to go through. And could you imagine having to type that out, and every time you added a new contract, like how would you do that dynamically? You couldn't. So at the moment, I won't be able to teach you how to make an array that has a dynamic size, because that requires a little bit of advanced knowledge. But for now, you can sort of go, okay, well, I'm going to need at least 50. I'm not going to need more than 100, so I'll just make it 100 kind of thing. It's a little bit inefficient, and it's kind of shit because you can run out of space. There's not much you can do about it. But for now, it should be basic concepts. Okay. What other cool things can we do? Oh, well. Let's do something, okay? Let's work out what the powers of 2 are. And let's do the first 100, okay? Once again, this isn't exactly the best example. Hang on. I have forgotten how to do powers of 2. Oh. All right. It is. Now, you can all see how bad I am at this, because this is the process of being a software engineer. No matter how good you are, you will constantly just like, I forget how to do 1 times 1. And that is just after you've just created the most amazing algorithm that takes a quarter of a second to search 1 billion people for one guy that has some specific thing in his name. It happens so often. So let's assign this to last, and like last times equal to 2. And that should do it. And then let's do the first 100. And then we'll also print it out again afterwards. Can you stop being shit, Mr. Computer? And let's not print this out. All right, let's see how it happens. I left 10 in, didn't I? Ah, jerk. All right. Whoa, I think I overflowed. I did. I overflowed big time. So that shows you some integer overflow. Let's make it a long instead. Now, if you don't know what a long is, you could probably figure it out from the connotation of what long would mean. I'm probably going to overflow again. I did, but I got a lot higher long. So that's how you do powers. Whoops, I didn't mean to push enter. So 1, 2, 4, 8, 16, 32, 64, etc., all the way up to whatever that number is. So it's 100,000, that's million, billion, trillion, quadrillion, septillion? 4 septillion, there you go. All the way up to 4 septillion. Math calculations are very useful for arrays and for loops and stuff. Obviously, you probably could have done that without an array if you're just going to spit them back out again. But then you can go, well, okay, I need to work out what my binary number 111111 is. And then you can use your array of powers of 2 that you've pre-calculated to work that out. Because the power operation, while not extremely CPU intensive, it's not trivial. Especially when you get into higher and higher numbers. So that can be kind of useful. I'm actually like struggling to think of a good use for arrays, and it's really annoying me. So let's walk it back a little bit. Let's actually make a program that uses arrays. I hit the wrong button. Cool. And this is a fairly common one. You're going to want to make a game, or you're going to want to make a program that takes a bunch of numbers, or like a phone book or something like that. So let's just say you want to take a bunch of names. So names. And I want to take up to 10 names. And I'm going to go for int I equals 0, I less than 10, plus I. Yeah, good lord. What is your name? And then we go, was it standard get line, standard cin, name. Yeah, cool. Once again, C in, C out, I very rarely use, like literally never. So I figured how to do things. So names I is equal to name. So that we're just getting player What are you complaining about? Missing closing quote. It's literally right there, mate. It'll run. I hope. Okay. What is your name player 1? It's going to be Jason. What is your name player 2? It is going to be not Jason. And 3 is going to be 3. And 4 is going to be 4. And 5 is going to be... Shit, what is 5 in a different language? It's Nissan Go. 6... I'm running out of languages I know, which is 1. 6. 7. Sete. Otto. 9. I've spelt it wrong. 10 is going to be Q. Ju. I don't remember what it is in Japanese, to be quite honest. Cool. I have entered 10 names for no reason. And now we can actually have a look, and we can see we actually have 10 names. And it's amazing. But let's walk it back a little bit. Let's go back to 2 players, and let's say we're going to go while true. So basically forever. We're going to say int current 0. Just bear with me while I think about what I'm doing here. Okay. And then our name. What do you want to do today? I mean, we're not going to give them any option to actually react to them, But just pretend that you are making this program and you are going to do something fun with it. And this is just one example of some of the silly things you can do. So if current is equal to 0, that is incorrect syntax. Whoa, funky. Oh God, what have I done? All right. Player 1 is Jason, player 2 is not Jason. Okay, Jason, what do you want to do today? Go outside lel. Excuse me. Okay, not Jason, what do you want to do today? Stay inside lol. Okay, Jason, what do you, etc, etc. Just go around and round and round. So you could imagine that as a game, you store all the player state in a bunch of arrays, whether it be 1 player, 2 player, 4 player, 12 player, whatever, and you can just loop through these arrays and get that person's stuff. Like first player will always be position 0 of their name, their score, their lives, their health, their money. And then when we get into the next lesson, my favorite, we will see how that all can go together. So arrays themselves are extremely simple in concept, but they are so extraordinarily powerful. A string, like your normal standard string, my name. This here, if you type it correctly and you hover over it, you'll see this. I'm pointing at the screen. I don't know why I'm pointing at the screen. That's come up, const char, open square bracket 6. Because the name Jason, it is 5 characters, and then the end of string character, 6 characters. That is an array of 6 characters. That is how a string works. So you've already used arrays. And then you can do cool things like for int I equals 0, I less than 6, because that's how big my name is. Not O, that is I, you massive idiot. And you can go, my name, I. Man, I hope they haven't changed this since I last used it. Let's comment all this out. And you'll see it actually goes down the name, because you can access each individual character as if it was an array, because that's what, if it was an array, because that is what it is. But the string itself exposes that extra little square bracket thing to say, all right, you can access like this, like an array. And a lot of things do. You have a thing in C++ and pretty much every programming language that's worth its salt called a list, which is exactly what you think it is. It's a list of stuff. The advantages of a list of stuff is it manages the memory itself, so you don't have to do arrays, and when you run out of space, you have to make it bigger. When you have too much space, you have to make it smaller. It does stuff like searching, sorting, getting first, getting last, and all that kind of fun stuff. And they're all dynamically sized, so it's all pretty incredible. But you can access element 0 using your array notation, which is your square bracket 0. And cool things like that. And you can also do other cool things, which I'm sure we will get into on the next one, when we learn about classes. Because classes are the second real big building block we're going to learn, besides your basic like data types and stuff and your ifs. But arrays allow you to build bigger things, dynamic things, because that's what programs need to be. They need to be dynamic. They need to be something that can react to, my cat's trying to get in, react to what the user is doing, rather than just sort of have this predefined path you can take. Because, you know, just imagine the case of you making like a simple game, but you can only, you know, support up to 3 guns on the screen, or 3 players in a multiplayer game. And then when you want to access a 4th player, you have to make a specific 4th player version. And when you want to access a 5th player, you have to make a specific 5 player version. And that would be so shit. But if you have a list, you have an array, you have something like that, something that you could just go, all right, I can support 100 people. I can make Fortnite Battle Royale on my command line, because I know arrays. I mean, you probably could, to be quite honest. I don't think it'd be too difficult to make command line turn-based Fortnite. I said optimistically. It would be shit, but it wouldn't be too hard. Anyway, the very last thing I will show you, because I always forget to do this, is initializing arrays the same way you'd initialize a number. So my number, or whatever number, is equal to 1. With arrays, it's a little bit different because you're initializing multiple things at once. So int my numbers, and you give it the size, is equal to, oh, could you stop that? Your curly brackets, your block, and then you just enter the values. So 25, 25, 25, 25, and 26. And you have initialized an array with 5 values. You don't have to put 5 values in, you can only put in 3 values if you really wanted to, and it will just sort of blank out the rest. I don't remember pushing the Windows button. Is there any other cool stuff we could do with this? Just looking through the notes. You could do other cool things, and it's where it kind of gets really funky, and I don't really want to do that at this episode because it's like really funky, but it's only been like 26 minutes, so let's go into it. Let's talk about multi-dimensional arrays. Ooh, spooky again. What is a multi-dimensional array? Well, this here is a single dimensional array. We have 5 guys in a line. Simple. Think about a map, as in a game map, a 2D game map. You have tile-based, or even an Excel spreadsheet is a good example. You have your tile-based map. This here is coordinate 0, 0. This is 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So let's add a new sheet and actually do that. So this is 0, 1, 2, 3, 0, 1, 2, 3 equals that's X. Man, I have not done Excel in so fucking long, and it breaks my brain sometimes, but we will get there. You do cool formulas. I have not entered too few arguments. Is value? Yeah, it's value, okay. So I honestly think that Excel is one of the greatest tools you can have as a programmer, because you can do cool stuff. Oh, you're only meant to lock the one. Oh, I'm locking the wrong one, aren't I? So X needs to lock that. See? Cool formulas. There we go. Let's say you have this. You can create a multi-dimensional array that would go, okay, at position 0, 0, I have an integer, which is the tile type, or the amount of enemies on the screen, or whatever else. And the way you do that is you go my map, or whatever variable you want to call it, and you go whatever size the first thing is, in this case it's 4, and whatever size the second thing is, in which case it's 4. And the way you put data in and take data out is exactly the same, but let's do it in a loop. 4 plus I. And this is where it separates the wheat from the chaff when it comes to programming, when you start getting into multi-dimensional arrays and multi-dimensional, multi-nested for loops and all that kind of really awful shit. J, you access the first dimension, then you access the second dimension, is going to be equal to whatever I plus j is. And then we're going to do the same thing to pull it out. I, j, equals my map. Man, this is gonna look like absolute trash. Love it. So it should be, it goes from 0, 1, 0, 0, 0, 0, 0, 1, 0, 2, 0, 3, 1, 0, 1, etc., etc. So let's remove all this stuff because we don't need it. Let's comment it out. And if you're using Visual Studio and wondering what the shortcut is for that, it's Control K, Control C. And I think Control K, Control U is uncomment. So I mean, that's a pretty lame thing to do. But when I made my first game, it was Battleship, and it would be a two-dimensional array and a while loop that you go back and forward with. And it would actually have a little bit of AI. It wasn't very good though. But what I've taught you at this point is enough to make Battleship. You could make Battleship with AI. If you really wanted to, you could make Battleship with AI using a two-dimensional array. Because you could go, okay, 0 is unhit, 1 is you've hit it but nothing was there, 2 is there's a ship here, etc., etc., etc. And you have your board and the other player's board, and you need like literally two variables, and you could make Battleship. Two-dimensional arrays. That is how I did it. That is how you can do it. And I hope you've learned something, because I feel like I've rambled for the last 40 minutes or 30 minutes about arrays. But the next time, the next lesson, class is in session. That is the lamest joke I've ever made, and I apologize. I will see you then.